I'm Crux Conception, which is a pseudonym for crisis intervention. I got 25 years of law enforcement experience. How many people have ever seen Silence of the Lamb or the TV show Criminal Minds? Okay, that's what I did. For 25 years, I sat across pure evil. I've spoken with John Wayne Gacy before he was here. I spoke with every famous serial killer possible known today except for one, and the person resides here. Anybody know who I'm talking about? Yeah, Jack the Ripper is probably the most famous serial killer of all time. But we're not here to talk about serial killing. We're here to talk about psychology and how to deal with psychology and coding together. And with that said, you're probably wondering, what is a former cop, a retired special agent, doing here at a tech conference? I'm going to say something, and I guarantee you at least 5 of you will shake your head and go like this. One thing that law enforcement and people in the tech have in common, that's one essential key, and that is we like problem solving. We like getting to the truth and to the answer. And I see 1, 2, 3, 4, 5, 6. Okay, so without further ado, my man here, Adam Tornhill.
Thank you very much, and good morning, everyone. So we're going to see what we software developers can learn from offender profiling. And we're going to approach this through the lens of technical debt, which is a factor that impacts us all. So what is technical debt? Well, we take on technical debt as developers when we choose to compromise quality in an attempt to deliver a feature a little bit faster, or maybe our understanding of the problem has evolved, so our design is no longer a good fit. Or maybe our design wasn't a good fit to start with, right? In any of these situations, the end result is the same. We end up with code that's much more expensive and challenging to maintain than it has to be. And technical debt is a huge problem in the industry. And that has been apparent through some recent research studies. And depending on which of these studies that you look at, you will see that the average organization wastes somewhere between 23 to 42% of their developers' time dealing with technical debt and bad code in general. So 42% waste. What does that mean? Well, it would basically mean that if I have a software organization and I employ 100 engineers, I get the output equivalent to just 58 people. Does that sound like a good deal to you? In reality, it's probably even worse, because with 100 people, there's also the additional coordination and communication overhead, right? So the actual waste is probably much, much larger. And it's not only about the financial impact, because technical debt also comes with a link and correlation to software vulnerabilities. So there are things like brain methods and large classes in general that are known to have an impact on vulnerabilities. And this is something that we're going to look at in much more depth further down in this keynote. Now, given what I just told you, you would expect technical debt to be really, really high on any decision maker's agenda, right? As a technical manager, this is something you obviously need to deal with. What do you think? How many organizations actually deal with technical debt and manage it properly? A few of you. That's very good. It's like 1 out of a couple of hundred. And that kind of matches what the researchers find, because what the researchers constantly find is a pretty depressing picture. It turns out that we developers are frequently forced to introduce even more technical debt, and very, very few organizations actively manage it. So I would like to conclude that in the wise words of Mel Conway, there never seems to be enough time to do something right, but somehow we always find the time to do things over and over again. And Mel Conway wrote this in 1967. So to me, it kind of seems that human behavior hasn't really changed. What do you say about that, Crux?
Actually, thank you, sir. Technology changes. Human behavior stays the same. There is no refuting that technology has drastically altered how we live, work, and play. But despite all the gadgets that are out and gizmos, human psychology has remained largely the same. That's why companies still use the same old marketing tricks. And that's why crime and hacking are serious subjects. I'm sorry, ladies and gentlemen. No matter the motive, hacking is a crime that can have serious consequences for both the perpetrator and the victim. For example, hacking can release, in the United States, there was a hack of computer data. People think it was a document, but it was a Supreme Court justice in the United States where our systems were hacked and information was given out, and it caused an uproar. It's still causing an uproar in the United States based on information that was leaked through the United States Supreme Court system. As technology evolves, our understanding of psychology must also evolve. We have to understand that it's the human mind makes the motives. It's the psychology of the human mind that gives us that motive, that desire to want to infiltrate, to want to defend, to want to justify reasons and actions. If we look at the history, throughout our history of time, it is true that history repeats itself. But when we think about motives, we can think about motives here in Europe. We can think about motives in Russia. We can think about motives in China, in the United States. It all has to do with psychology. The person who's making those motives in those countries I've mentioned, think about the psychology of the leaders, the psychiatric, what's going on inside their heads. There is one area where those two worlds have come together, and that's hacking. While some hackers engage in hacking for positive reasons, such as finding and disclosing security vulnerabilities, some hackers like to do it just for the pure love of it. They like to do it because they're upset with the politics of the organization, just like Edward Snowden. He was upset, he was frustrated with the politics of the organization. When AT&T was hacked, the individual who hacked was upset with the politics and the structure of AT&T. This is their way to reach out. Some people spray paint, some people hack. There are a lot of people out there who don't care about the law and don't care if they go to jail or not, whether their reasons. You can have people that protest and they go to jail for a cause, for a beneficial reason. And you have some people just don't care, that know that what they're doing is wrong, and they continue and want to break the law. Many companies see hacking as a crime and react accordingly. And some don't. Some just let it happen and let it go by the wayside.
And one of the reasons, of course, that human behavior hasn't really changed is because biologically, we have been a very stable entity for 40,000 years, right?
Yes.
So we more or less try to attack modern technology with a Stone Age brain. And this is really, really challenging because the human brain never really evolved to deal with the level of detail that programming requires. And to try to make it more specific what I mean, please have a look at this piece of source code. I know this is an Elixir conference, and this is C++, right? So most of you probably aren't C++ programmers, right? I used to do a lot of C++. I've been a C++ developer for 10 years. And yes, I know those are 10 years I never get back. But my point is that even to me, with that experience, this looks really, really challenging. It's really hard to understand. Now, imagine a typical system where you have hundreds of thousands, potentially a million lines of code that looks like that. There's no wonder that it's challenging to identify security vulnerabilities or technical debt in a code base at scale. So what can we do about this challenge? How can we bring visibility to code and find a technical depth needle in that digital haystack? Let's start by having a look at some traditional approaches and see how they fail. One fairly popular approach is to use static analysis to try to identify technical depth and code that's challenging to deal with. And the first time I saw this attempted was actually here in London. I visited a client many years ago, and prior to my arrival, they had used a tool capable of quantifying technical depth. So the way it works is that these tools, they simply scan the source code, they check for a number of rule violations, and then they have a cost associated with each one of those violations, and they sum it up. So this organization, prior to my arrival, they have taken this tool and thrown it at their 15-year-old code base. And this tool happily reported that on your 15-year-old code base, you have accumulated 4,000 years of technical debt. 4,000 years of technical debt. I mean, to put that into perspective for you, 4,000 years ago, that was here. That's the start of recorded history through the invention of writing. So, when telling that story, I'm always curious, what kind of programming language did I use? A Fortran? Well, I do understand that in reality, a lot of that debt grew in parallel by having hundreds of engineers working on it. But still, what do we do with the end result? How do we act upon a number like that? It's definitely depressing, but is it actionable? Where do we start? So my point is that quantifying technical debt might be an interesting exercise, but it's simply not actionable. More importantly, we can never, ever prioritize or quantify technical debt from code alone, because the cost of technical debt is not the cost of fixing the code. That's the remediation cost. The cost of technical debt is the additional time we need to spend to deal with the consequences. But still, we somehow need to manage this problem, because we're always going to have this trade-off between improving existing code versus adding new features, right? And it's a balance that's going to shift over time, so we need to prioritize. How can we do that? And in particular, can we use an exciting technique like offender profiling, like criminal profiling, to help us with that? So Crux, please walk us through it and explain how criminal profiling works.
Okay. Criminal profiling is the act of profiling and using psychology to determine a person's characteristics and their traits. So it says up here, the criminal profiling process is defined by the FBI as a technique used to identify the perpetrator. And we're going to break this down here and talk about it's a system to help profile criminals and assess the psychology of crime scenes. Psychology is also used to evaluate the criminal act itself. This evaluation process assesses why the crime was committed and how it was committed. For example, psychology can evaluate whether a crime was premeditated or impulsive. It can also assess whether the perpetrator had any specific target in mind or whether the victim was chosen at random. By understanding the psychology of the criminal act, ladies and gentlemen, law enforcement officials and yourself can use more effective strategies to prevent these type of crimes. Now, I pause when I talk. It's a method I use to see if you're listening. Because, ladies and gentlemen, I truly believe it is not some sweaty kid in a basement at his mom's house eating chips, hacking into a system. Someone in our agency, in our department, in our company, takes an insider threat, an inside person. That person, as I mentioned before, upset with the psychology, upset with the politics, the way the structure of the business is going. These individuals will make comments around the water cooler. They will make statements. They will talk about it. They will make statements on social media. They will make inadvertent statements about their upset and their displeasure with your company. Comprehensive analysis of the victim. This is victimology. For us, for everyone here, it'll be the company. It'll be the individual that gets that email where they click on that link, the phishing email. It'll be that individual that's on social media that gets social engineered. Hey, how you doing? What you do for a living? Where you work at? They're gaining tons of information by you just answering those questions. Evaluation of preliminary police reports or reports from Adam or reports from your forensic division. Those are keys to look into. These are frequently played as a vital role in the evaluation of the process.
Thank you. So we're going to return and learn much more from Crux about criminal profiling in just a minute. But before we go there, I would like to see if these really are techniques that we can use in software. We need a way of visualizing our crime scenes, our technical dept crime scenes. We need a way of visualizing code, and more specifically, we need a way to visualize overly complicated code, because that's the code at risk. So how can we do that? Well, if you read up on the different code complexity metrics that we have available in the industry today, you will find that there's never, ever a single metric that can capture a multifaceted concept like code complexity. And we are doomed if we start looking for that, because software complexity is way too multifaceted. So one concept we've been working on over the past 5 years is something that's called code health, which is based on an aggregation of multiple metrics, 20 to 25 different metrics, depending on program language. And the way it works is simply that we identify these 20 to 25 different code health issues, code smells, if you like, and we measure them for every single module, every single file in the code base. And then we kind of aggregate them, and we score them against a baseline, and that makes it possible to categorize every single piece of code that we have in our code base as being in one of 3 different categories. And you see an example here. I'm going to walk you through the visualization in just a minute. But basically, each file can now be categorized as being either green, so green code, that's healthy code. This is where we want to be. This is code that's easy for me as a developer to pick up. I will be able to understand it, and I can work with it safely. There's low risk that I'm going to introduce a vulnerability or defect. Then there's the yellow area. That's the warning space. So this is where we start to take on technical debt, and we need to be extremely careful, because otherwise we end up in the red category. And the red category is where we know that we have a high degree of technical debt, and it's going to be really expensive to reverse that. And just to give you an idea on what kind of code health issues we typically look for, it's typically things on multiple levels. So it might be class design issues, module design issues like low cohesion. So low cohesion is basically when you implement way too many responsibilities in a single module. So now that module has many different reasons to change, and there's also the risk for things like unexpected feature interactions, which frankly are some of the worst bugs you can ever have. Then there are different implementation smells and function level smells. One of my favorites is brain methods, also known as gut functions. So this is simply these overly complicated methods or functions, right? Tend to be really large, tend to contain a lot of logic, and they tend to be very central to the module. So each time you need to make a change to that module or class, you end up in the brain method, and over time typically grow even worse. Now, to make this specific for you, I want to visualize the code health of a code base that I think all of you are familiar with. It's a code base called Phoenix. So this is a visualization, a code health visualization of Phoenix. And what you see on screen here is roughly 40,000 lines of code. And I'm going to walk you through the visualization so you know what you see. If you take a look at these large circles, the ones I'm hovering over right now, each one of those represents a top-level folder in the Phoenix Git repository. So if this was one of your code bases, you would immediately recognize the names of those folders as important subsystems or high-level components. As you see, it's also interactive, so I can zoom in to any level of detail that I'm interested in. And once I get to the lowest level of detail, I will see that each file with source code is visualized as a circle. And you see that those circles, they have different size. That's because size is used to reflect the number of lines of code. So the more lines of code we have in a file, the larger the radius of the circle. The important information here is the color, because the color reflects the code health category. And we see here, this part of Phoenix looks like to be a very healthy green space. Now, before I continue, I have to admit that as a speaker, there's one thing I strongly dislike about Phoenix. It looks too good. And my job as a speaker is simply much, much easier if there's a little bit of a mess there, right? But hats off, and on a more serious note, hats off to Phoenix. It's one of the best code bases I've seen from a code health perspective. Looks really, really good. And we're going to return to Phoenix in a couple of minutes, but before we do that, I want to show you some examples from other well-known open source projects, so you know what a more typical code base looks like. So these are code bases that you're likely to be familiar with as users. So to the left, we have React, a UI library from Facebook. And to the right, we have Core CLR, the common language runtime from Microsoft. And I'm a big, big fan of visualizations, because visualizations tap into one of the most powerful pattern detectors that we have in the known universe, the human brain. And this means that even if we've never seen this source code before, we can immediately, in less than a second, we can immediately tell where are the strong parts and where are the weak parts, and how deep do any potential problems go. And this is some very real power. So just to give you an example, if you look at React, you see that, okay, React seems to be pretty mixed with green and yellow code, and then there's this cluster of red code in the React reconciler. So if this is my project or my code base, then this is information that I need to be aware of, because that red code is very likely to constrain me as a business. It's going to constrain what we can do with that code base. Now, if we look at Core CLR, I'm not sure if you can read the text, but what you see there is that Core CLR is actually 8 million lines of code. So this is a truly large code base, right? And you see that there's a lot of red code there right in the middle. It almost looks like this bacteria culture gone mad, right? And this simply means that it's going to be much more challenging if we want to address technical debt in Core CLR, if we want to improve quality. So towards the end of this session, I'm going to show you another technique from offender profiling that we can use to prioritize technical debt, even in large code bases. But already these examples kind of show that it's obvious that we somehow need to narrow the search space when prioritizing and dealing with technical debt and code quality. And this is where I think that we can learn a lot from criminal profiling. So Crux, please continue that exciting journey you took us on.
Sure. How can we narrow down the search for profiling? And the answer is to that one, let me get my notes here, sorry, apologize, is that they are assisted by, criminal profiling has grown rapidly since the 1970s. And it consists of a team of a manager, 7 profilers, and a crime analysis. These individuals are assisted by a criminal profiling coordinator. Criminal profile may also invite interview techniques for the interviewer. For individuals such as Adam, we give our information, we give our findings to Adam. Adam uses that as a tool. It's not going to solve everything. It's not a magic wand where it's going to solve and say, bam, you're the suspect. Sorry, Alex, I didn't mean to call you a suspect. Can I have apology? There we go. Thank you, sir. All right. Instead, you'll be the suspect. And you could be the suspect, or you could be the suspect, but it's up to Adam to look at these reports and decipher my findings, or anyone with a background. Adam himself has a background in psychology with these findings. Step 5, using psychology to evaluate a computer forensic report. That's the cool part. Using psychology to evaluate a report is important. It's a vital step in solving the crime. By carefully analyzing the information that's contained in the reports, investigators can develop a profile of the perpetrator. And this individual can gain insights into a person's motives and methods. Methods, not methods. This can identify leads and evidence at a crime scene or within a forensic report. In many cases, the evaluation of computer forensic reports can be the key to solving a case. For example, in the ransomware attack in the city of Atlanta, United States, investigators quickly identified the culprits by analyzing the preliminary forensic reports. In another case for a hacker who stole data from a major retailer, investigators used the information from the forensic report to track down the suspect and bring him to justice. Step 6, development of a profile with the critical offender characteristics known as COP. This is a psychological profile of a prolific or a serious crime that has helped police identify or apprehend the suspect. This includes the physical, behavior, and psychological characteristics of an offender, and the information about their modus operandi, MO, that they are known to use. COPS are developed by psychologists and other experts who analyze crime scene evidence, witness statements, and other data. These individuals and this information can be used to narrow down a pool of suspects. As you notice, I just said Alex was a suspect and this was a suspect. Alex is not a suspect, he's a decent person, I'm sure of it. But it was just an example. It'll narrow these 3 individuals that I pointed out to 2, then it can narrow it down to 1. Again, criminal profiling or psychological profiling is what it's called today. In America, it's a no-no to say criminal profiling nowadays. We have to say behavioral profiling or behavioral analysis. I think criminal profiling sounds cooler. It does, sounds like there should be a theme song to it, like dun dun dun. So what is geographical profiling? Geographical profiling is an investigative support technique for serial crime investigations. Serial meaning continuous, non-stopping. Okay, investigations can produce hundreds of tips resulting in an overload of information. So therefore, police need effective methods, and they need to prioritize you, your security division, your security agency, whoever the head of your security division needs to prioritize these findings to determine the likely area of offender residence. Geographical profiling. This profiling focuses on the geographic of the crime itself, the offender hunting behavior, and targeting a relationship to linkage analysis. We will get into those in a second. Selection, psychological profiling, crime site, the crime scene, the typology, the type of crime it is. We don't have to worry about the child murderer in this case because this is hacking. Case examples, Jeopardy, but this is what geographical profiling contains. It gets all this data and information. Investigative strategies, surfaces on how geographic profiling works. It's a crime-fighting tool. Profiling is a tool. It's not a solve-all. I want to let you know it's not a solve-all, but which means that what the good thing about it is it works. I've done it for 25 years and it works. And you know the good thing about it is you can do it too. You don't need a background in psychology. You don't need a PhD. You don't need to be a law enforcement officer. You don't have to. You just have to have people skills and be able to study people. For myself, when I profile somebody, I start from top to bottom. I go from their shoes all the way up. When you see me in public, off stage, my shoes are not tied. They're loose. And you know what that means? That's a person that likes to cut corners. Is that mine? Or is yours?
That's yours.
Okay, geographic crime patterns are clues that once decoded can point to the offender. And it can. If it's done right and it's done consistency and all the information is piled together, you have to be meticulous at this when it comes to geographical profiling. Locations. What are the location types? Where are they connected to the crime or the crime series? For example, are they hacking telephone companies? Are they hacking oil companies? Who are they targeting? Why are they targeting oil companies? And it's not just because they have the most money to give for ransomware and they'll give it up like that, although that is a deciding factor. The main key factor, you have to find out, why are they pinpointing oil companies? Why are they only pinpointing telephone companies or social media companies? Time. When did this crime occur? Date, the time of the weekday. That's very important. If you look around the world of people who are honest at reporting hacking incidents or ransomwares, which in the United States is going to become mandatory soon, as July the 1st, it will become mandatory that you have to report that. But what times, and this is the main reason why it helps investigators, it helps profilers narrow down better. What time? If it was at 7 o'clock, and the hacker, we can find out if the hacker lived in America, lived in Europe, the location, and we can get a better description. That pins it down to a lot. If you could find out if they're from Europe or the United States, we can definitely say it's a probability that's a male white. We could start from there. What was the weather like? That's more of a physical crime nature, but I put it up there to give you a sense of what geographical profiling can do. How much time was there between the crimes? How much time did this person have to do to send that email or contact the head of AT&T or contact the head of your organization or some other organization? How are the crime locations accessed? How is this individual able to get inside your company? You have to ask these questions, ladies and gentlemen. How was this person able to penetrate into your system? The how is the most important one. If you can answer the how, I hate saying the word trust me. So I'm gonna say this, based on my education, my years of experience, and the ability to do this job for 25 years, I know what I'm talking about. You have to get the how. What purpose did the crime location serve? What purpose did hitting or attacking this agency or this organization, what purpose did it serve? Why would someone have to go after BP gas? Why would someone want to hack a school corporation or a government organization or a law enforcement organization? I'm waiting for that to happen. I'm waiting for the FBI. I don't want it to happen, but I'm waiting for the FBI or Secret Service or DEA, ATF to be hacked. I'd like to see how fast that gets solved. And trust me, I believe it'll get solved very fast. Target backcloth. Where is the target group? And where is it not? Where is the target group? Who's the target group nowadays? We have to find out. Target groups nowadays, ladies and gentlemen, in America, I can start seeing gun manufacturers being hacked. And there we go, again, for a motive, a purpose. You see a gun manufacturer being hacked, I'm on the side saying, okay, let the hacker do it. I'm tired of seeing people get killed. So that person is a Robin Hood. That person is so. Therefore, again, that motive, is that necessarily an evil motive when they're hacking gun companies? Yeah, my friend there is right. In America, you listen to news. In America, it's off the hook. It's ridiculous. The hunting method did the offender use? What hunting method did they use? How did they spy? How did they check out? How did they recruit an inside person? Ladies and gentlemen, again, I know what I'm talking about. They recruit inside people first. If you worked for AT&T, and I keep saying AT&T, I'm sorry. If you worked for Sprint Mobile, and you and I became your friend. I social engineered. We talked on Facebook. We talked on social media. Next thing you know, we're out at a pub buying drinks. I got into your life, got in there, and I asked you, hey, you think AT&T would want to pay $10 million if they were hacked? And you had a few drinks, and you tell me yes. And I scoped you out so well that I believe what you're saying. So how do they hunt? Why are these sites and not others? Because we were able to infiltrate. We were able to social engineer a person, an inside person. That's why. What is the offender likely transportation? That's more of a more physical, violent type of nature crimes. Thank you.
And the first time I heard about geographical offender profiling, I was like, wow, what if we could do the same thing for code? Because what the geographical offender profile does, in my perspective, is basically that it projects a probability surface onto a map, onto a geography, right? That narrows down the search space significantly. So what if we could do this for code? What if we can take those hundreds of thousand lines of code, narrow them down to a few files or modules, where we know that with a very high likelihood, this is where our offender is. And that offender could be technical debt, it could be overly complicated and potentially vulnerable code. That would be a huge win. And this is what I tried to do with your code as a crime scene many years ago. And I want to do now is to use those code as a crime scene techniques to do a geographical offender profile of Phoenix. So we're back to visualizing Phoenix. It's the same type of visualization that you saw before with CodeHealth, only now the color carries a different meaning, because the color represents developer behavior. So what we do now is that we trace the steps that we, as developers in Phoenix, did when building that code. So I look at the Git log, and I simply count how many commits have we done to every single file, and I use that to represent change frequency. So the more red something is, the more work, the more commits we have done on that part of the code. Again, it's interactive, so we can zoom in on the top hotspots here. And we're going to do that. We're going to look at a couple of hotspots and see what we can find. So what we see here are two test cases where there seems to be a lot of development activity. Now, what we want to make sure is that the code health is really, really high in this part of the code. And the way I approach this is that I typically start by drilling deeper. Before I even pick up the code and look at it, I drill deeper. And the way I do that is by using another behavioral code analysis technique known as X-ray. So the way our X-ray works is that when I find a hotspot, I take that code, I parse it into separate functions, and then I look at the Git log and see where do each commit hit over time, and I sum it up so that I get hotspots at the function level. And this is what allows me to do small and actionable refactorings based on data from how we actually work with the code. So let's look at this particular hotspot in Phoenix. It's called New Umbrella Test, so test suite. And this is what the X-ray analysis shows us, that the number one hotspot at our function level is called New with Umbrella and Defaults. It's a test that has been modified 69 times. So lots of development activity in that particular test. And from a perspective of technical debt, development activity, it's like the interest rate, right? The more development activity, the higher the interest on any technical debt there. And we can also see that this seems to be a pretty large unit test, 274 lines of code, so pretty large for a single test, I would say. Now, once I've narrowed it down, I can start to investigate that particular function and know that this is most likely where I have the largest return on investment if I do any refactorings, right? Since we work so much in that part of the code. So let's dig down and let's look at the code. And again, let me start with a small disclaimer. I'm a former C++ programmer, right? I don't really know Elixir. So what you're going to get now is an outsider perspective on the code. So when I picked up that test case, one of the things that really kind of stuck out to me is that I saw this repeated pattern that's repeated a couple of times throughout the unit test, where we do some kind of check and see, is it a specific version of the system? Then do this, otherwise do that. And we see that same pattern kind of recurs in another part of the code, and I think there's a third one as too. And to me, what I would do when I see this code is that I would really, really consider to separate the general from the specific. So I would most likely take all that code that's specific to certain versions of the system, and I would extract them into separate test suites. Then that would give me a much, much cleaner separation between, okay, what's the behavior for those versions, for the new versions, and what's the behavior for the legacy versions. And of course, you could make the argument that this is only test code, right? So does it really matter? And I have seen it throughout my career that we developers, myself included, we tend to make a mental divide between application code, where we know this is really, really important that we keep it nice and tidy and easy to understand. On the other hand, we have the test code, and most of the time we're happy if we get around to write any of it at all. And I think this is a really dangerous fallacy, because if our tests don't receive the same love as our application code, and they lack in quality, they will hold back our overall efforts. So to me, there has never been a thing that's just test code. The big win with hotspots is that they send us a positive message. And hotspots become even more important the larger our code base is. And to show the other extreme, I want to go back to core CLR. Can you remember the bacteria culture gone mad that we talked about a couple of minutes ago? So this is a hotspot analysis of the same code base. And what a hotspot analysis does is that it gives me actionable advice, because it points out that most of the code in any code base, this is true across all code bases I've ever analyzed, and I've probably analyzed 400 or 500 code bases by now. So this is the way code evolves. Most of the code is stable, meaning that we rarely, if ever, work with that part of the code. And that means that that's the part of the code where we can safely live with a certain degree of technical debt because the interest is so low. The hotspots, on the other hand, make up a pretty small part of the code base, so 2-3% maybe. And those are the parts of the code where even a minor amount of technical debt can quickly become quite expensive. So, before we wrap up, I also want to point out that technology and coding is about much more than just the code itself. In particular, communication is an important thing. So Crux, is communication, is that an important part in law enforcement too?
Yes, communication is key of all investigation. Ladies and gentlemen, when you hear the word 9/11, you think of the United States and the towers crumbling down and terrorism. What you may not think if you didn't study the case, and I don't expect you to, you will realize that there was a great deal of lack of communication through our federal agencies. Secret Service didn't talk to the FBI. FBI didn't share information with the Secret Service or Department of Homeland Security. Matter of fact, that's why Department of Homeland Security was created. Other information didn't say that, and we see that today throughout the world. You know why? I can give you a global example. There was an epidemic 2 years ago where the lack of communication made this a prolonged, agonizing, horrific event. Communication is key, ladies and gentlemen. We need to talk to one another. You individuals who work in security, you need to communicate with each other. Individuals who get funny emails asking about your jobs, or you see a stranger on social media and they ask you something about your job or where you work at. Report that, because ladies and gentlemen, that's another topic we could talk about later, social engineering, and they are good at that. Companies and investigators can avoid serious mistakes and ensure that justice is served, because communication can used effectively, it can help build unity within a team by creating a sense of trust amongst us all. And finally, this is essential in law enforcement and in business and in hacking, where investigations often involve sensitive or dangerous subjects. By working concurrently and using clear lines of communication, both the companies and the investigators can increase their chances of success. Thank you.
Yeah, and as a software developer, speaking of communication, and when I heard Crux tell me this stuff, I kind of immediately started to think about legacy code. Because what if we can no longer communicate with the people that used to work on the system? So before I dig into this final case study, I want to show you a shared definition of legacy code. So when I think of legacy code, I'm referring to, first of all, code that somehow lacks in quality, and more importantly, code that we didn't write ourselves. Right? And this second part is really key to understanding legacy code. And this kind of got me thinking, given the high developer attrition that we have in the software industry, can we do a thought experiment? How quickly can we take a current code base and turn it into legacy code? Can we have something like a legacy code making machine? So again, let's study this on Phoenix. Let's see, what would it take to make Phoenix a legacy code base? Now, if you look at the numbers from GitHub, you see that, again, 40,000 lines of code, written by more than 600 contributors to the actual source code, right? So if I would take on my manager hat, I would say that with 600 developers, if I lose 1 or 2 or even 3, it doesn't make a big difference, does it? Right? Still have like 598 people that can keep up. So no issue, no risk at all. Of course, reality is a little bit more complicated and nuanced. So let's study the impact if a core developer leaves Phoenix. And to study this impact, we need some behavioral data. And how can we get that? Well, remember, you are all in version control wonderland. So we have all the information we need in the Git log, because our Git logs knows exactly which developer that wrote which piece of code. And this is information that we can aggregate, and we can use that to simulate different offboarding scenarios. So that's what I want to do now. So again, we're back to the same type of visualization that we saw before for Phoenix. And again, the colors carry a different meaning. So everything that's blue, that means that this code is written by the current team, right? So this is code where somewhere in that organization or amongst the contributors, someone knows each piece of code. What I'm going to do now is to see what happens if 2 core developers leaves Phoenix. And I see a list of the people who have written most of the code to the right. So what I'm going to do now is to offboard them one by one and see what the impact is. So let's start. What happens if Chris leaves and Jose? Let's combine that. Let's pretend that we are the managers of this code base. Should I be worried? Yes. A little bit, right? Mm-hmm. So this is really, really, really important information. And the reason I show you this is because I really like to drive home the point that there is so much more to code complexity than just the code itself. In particular, social factors like how familiar we are with the code strongly impacts how we view it. And in particular, we tend to overestimate the complexity of unfamiliar code. And unless we have a complete picture of both the technical side and the people side of code, we risk to address the wrong problem. So we have come to the end of this session, and I like to point out that when we as developers bring criminal profiling techniques into software, then it's not to replace anything, save maybe for wild speculations and guesses. Instead, I view these techniques as a complement to our existing expertise, your existing experience. Because building software at scale will never be easy, and I'm pretty convinced that we as developers, we need all the support we can get. And we hope that this session has inspired you to investigate the topic in much more depth. So if you would like to try this out on your own code, then the tool I've been using for all these visualizations and analysis is CodeScene. You can just go to codescene.com, and there's a free community edition. If you want to use it on open source, you can even get a nice green code badge to put in your GitHub. And if you work on closed source, then you can try it out for free for 1 month. So before we leave time for questions, I'd like to take this opportunity and say thanks a lot for listening to us, and may the code be with you. Thank you.
Yes, thank you. I'd like to thank the organization itself, because I don't think, I've been speaking for about 2 years now, and I've spoken at a lot of tech conferences, and I don't think I've seen anything like this, where they get 2 individuals with 2 different backgrounds, both culturally and professionally, on the same stage together. And I just think I was just honored to be asked to do this, and I want to give a hand to the organization for doing that. So everybody, if you can get a hand to them, this is great. Thank you. Oh, and also on my, I noticed that when I teach how to profile social media accounts, if you get with me, I won't profile you, please. I know a lot of people saying, oh, I won't click on there because he'll profile me. I won't do that. So go ahead and check me out, please. Yeah.
Thank you very much. Do we have any questions? I'm not sure. Mike's hot yet. We're going to get it working.
No question.
Any questions?
Hey, by the way, I have a new batch of Code as a Crime Scene stickers, and you really need one of those, so please grab one after the talk here.
So I've got a question. We've heard a lot about investigating code quality and code tech debt, but do you have any sort of insights about code documentation health and tech in there?
I do. One technique that I haven't talked about today, but something I've been using a lot over the years, is something I call complexity trends. And it's basically a way for me to visualizing code complexity, because I always think that there's much more information in trends than there is in absolute values. So if you kind of plot the complexity growth of a particular module over time, then that tends to be something that gets people's attention, right? It's really, really powerful to see that, okay, this code not only is it complicated today, but it's actually growing worse. And when I did these trends, what I also did was that I also added another data point. I added the number of lines of documentation over time. And the reason I haven't gotten so much experience with it is because for most code, it kind of looks like the x-axis, right? We completely underuse documentation in the industry, and I think that in general, as software developers, we are not so good at writing documentation, which is why we end up in these really strange debates about should we even comment our code at all? If we write clean code, we don't have to comment it. And I think that's definitely the wrong path, because good documentation shouldn't mimic what the code already tells, right? It should tell us all that stuff that we can't read out of the code. So it was a very, very long answer, maybe not even to your question, but I know I answered some question.
Thank you.
Thank you very much for the presentation. Very, very interesting subject, and very beautiful visualization as well. I was wondering why the choice to use circles to visualize everything versus, for instance, using a tree map, which is like nested rectangles.
Yeah, thanks a lot, first of all. I'm really happy to hear that. So I think the circles that you see, it's a style that's called the enclosure diagram, and it's like iteration 37 or something like that, because I've attempted every single visualization that there is. I used 3D, I used tree maps, and I ended up using these circles because what I really, really like about them is that, first of all, they're two-dimensional, so they kind of mimic the maps we use in the real world, and I really like that. It's a powerful metaphor there. And what I also like is that they scale really, really well. So yeah, if you grab me during a break, I can show you a visualization of the Linux kernel, which is like 20 million lines of code. And even at that scale, you can immediately point out that, yeah, this is where I need to go. And there's simply no way of doing that with tree maps, in my experience.
Hey, do you find that any languages specifically might trend towards like a cleaner diagram or whatever, and some might trend towards a little bit messier on average? And what about Elixir?
God, that's such a dangerous question. So let me put it this way. I do a lot of presentations at developer conferences, and depending on what community I visit, I want to have kind of showcase different things, right? So if I want to show the problems with overly abstracted code, I Google GitHub Java trending. If I instead want to show overuse of mock objects, then I Google for C# code. And if I want to find some real complexity bomb, then my default choice is C++, right? So I do think that as communities, we have different values, and you tend to find different problems in different programming languages. That said, I'm a little bit biased because I'm a functional programmer. I write most of my code these days in Clojure. And I do think that functional programming, yeah, we do have technical debt in functional programming too, of course. We do have overly complicated code. The key is that without side effects and without mutations, it's simply so much easier to refactor that code. So it tends to be lower overall general. That's my impression.
We've got a couple of questions from the online team. So the first one is, does a hotspot actually indicate that there's a problem with the code?
No. So a hotspot doesn't indicate that there is a problem with the code. What a hotspot tells us is simply that its code is highly relevant. So hotspots is all about importance, right? So in your code base, if we look at like Elixir, you will see that let's look at Phoenix Codebase, for example. You see that the top hotspots, if they're all green, then you're in a very, very good place, right? But again, you need to have both those perspectives. You want the hotspots to prioritize, this give them the relevance, and then you want the code health metric to get the quality, right? To see if there is any tech debt. So it's a combination that makes it possible to manage technical debt.
Thank you. And then the final question is for Crux. How long does it take to become a good criminal profiler?
It takes people skills. I mean, I just happened to Hopefully, if I'm here next year, I'll be Dr. Concepcion because I'm working on my PhD in forensic psychology. But what I realize is I wasted a lot of money doing that. Wasted a lot of money going to school because all it takes is people skills and communication skills and how to talk to people. That's all it is. And just basically sometimes how to just shut up and observe. Like I said, I go from top. When I profile somebody, when I used to profile, I go from top to bottom. I go from their shoes all the way up because clothing in both female and male tells a lot about somebody.
All right, well, I think that's enough questions for now. We have some breaks out there, but let's give Adam and Crux another hand.